Hey everybody, this is Mr. Beckstrom, and I got a request for this problem right here. Looks like it is number 15 in section 3.7, and this problem is going to involve multiple rules. And let's talk about how we figure out which ones to apply first, and then which ones to apply second, and so on and so forth. So the main idea here is that I want to set this up as some kind of situation where I have only two functions. So I want to designate one thing as one function and the other thing as the other function and start from there. And if I do that, then if I want to call e to the 6x my first function, and then 2x minus 9 raised to the 9th power, my second function, then this is, and we'll call this like f of x here, right? We'll call this g of x. Then this is the product of two functions, right? So I can encapsulate the entire problem as the product of two functions. So I'm going to start off using the product rule and then see what happens from there. So remember the product rule. It's the first times the derivative of the second plus the second times the derivative of the first. So I always like to just go through and figure out which one, what is what. So I got the first function, the second function, the derivative of the first function, and the derivative of the second function, and then I'll plug them into there. So the first function is just going to be e to the 6x. The second function here is just going to be 2x minus 9 raised to the 9th power. The derivative of the first function, I'll do that off to the side. So we want to find the derivative with respect to x of e to the 6x. And here we're going to apply the chain rule. Remember, the chain rule is most often used with e functions, trig functions, and like binomials or trinomials that are raised to a power. That's where we need to really think about the chain rule. So here, this is going to be equal to the derivative of the outside function, and the derivative of e to the x is just e to the x, so the derivative of the outside function is just e to the 6x. It always, for e functions, it always starts off as the original, and this is going to be times the derivative of the inside function, and the inside function is always the exponent, so using the power rule there for the exponent, the derivative of 6x is just 6, so I can write that as 6 e to the 6x, and that would be the derivative of my first function. So let's write that over here. 6 e to the 6x. I'm going to do the same thing for my second function. Notice that this is something in parentheses raised to a power, so I'm going to apply the chain rule again. So the derivative with respect to x of 2x minus 9 raised to the 9th power. Well, first I'm going to find the derivative of the outside function, so just pretend everything in the inside is just some variable. So that's just going to apply the power rule, so you bring the 9 out front, you keep whatever's inside here, so 2x minus 9, you reduce the power by 1. So that's the derivative of the outside function. And then we're going to take we're going to multiply that by the derivative of the inside function. So the derivative of 2x minus 9 is just 2. So when we clean that up a little bit, we're going to get 18 times 2x minus 9 raised to the 8th power. So 18 times 2x minus 9 raised to the 8th power. So now we're going to actually go through and apply this product rule here. So the derivative of this function, so y prime, or dy, is equal to the first term, which is e to the 6x, times the derivative of the second term, times 18, 2x minus 9 raised to the 8th, And then we're going to add the second term, which is 2x minus 9 raised to the 9th times the derivative of the first term, which is times 6 e to the 6x. And then it is just a matter of cleaning this up a little bit, pulling out some stuff. So I have an 18, a 6, I can pull out a 6 from there, and then I also have an e to the 6x. So if I pull out a 6 e to the 6x, then with this first term here, I am just left with 2x minus 9 raised to the 8th. And, I shouldn't have put that one there. And then plus, and we factored this entire thing out, so that's just going to be 2x minus 9 raised to the 9th power. And that's probably all I can really do with that at this time. Make sure I put that parenthesis in there to close it up. If you have any questions, please let me know. Well, looks like I can probably go a little bit farther on this. I can actually pull out a 2x minus 9 raised to the 8th power from both of those as well. And then you'll just have a 3 plus 2x minus 9. And you can do that as well. Let me check to see how far they went. All right, so the book did go, or the homework did go a little bit farther. I'm not sure if it would take this answer. It might tell you need to keep simplifying. But I did go ahead and factor out this 2x minus 9 raised to the 8th power here, which just leaves me the 3 from this term and a single 2x minus 9 from this term, which I did right here. And then I just combined that to make it 2x minus 6. Finally, I just factored out a 2 from the 2x minus 6, which gave me an x minus 3, and pulled the 2 out to the front. So this is actually what they have in the book. All right, guys, if you have any questions, I know this is really tricky, kind of getting this to look right, but please let me know, and I hope everybody has a great rest of your week. Thanks.